And I'm very excited to be here. It's great to see so many people attending this conference and so many interesting discussions going on in the chat. And so many both new and old or familiar faces, I should say, to me, not necessarily old. So that is very cool. And today we will be talking about faces, more specifically about robot faces. And we have some very interesting new developments that I want to give you a sneak peek of. But before we do that, I would like you to give you a little bit of background, take you back a few years in history. So in my department at KTH, Royal Institute of Technology in Stockholm, about 10 years ago, we were part of a European project. And the goal of this project was to develop a robot that could use speech and gesture to communicate with people. And we were super excited about this because we had been working with we had been working with speech and dialogue systems and also talking heads and trying to accomplish face-to-face interaction with machines for quite some time, but we had never worked with a proper robot. So this was really the first time we were going to get our hands on it. And robots and speech technology were such a perfect fit in our minds to create this unique face-to-face interaction where you can exploit all these multiple modalities and so on that we were and still are really into. So this was really an opportunity, and also surprisingly little had been done in that field at the time. So the robot in question was a pretty sturdy and complicated contraption that was built by one of our partners in the project. And we were particularly interested in the head because it had dozens of servos that could move the little features around, the eyebrows, and the lips could shape, and it could even flap its ears. One thing though, as soon as we started to work with this head, we were struck by the fact that as soon as the motors in the face started moving, they would make so much noise. So any attempt at a conversation with the robot was futile. And then after a few weeks, they also started malfunctioning. So our enthusiasm faded a bit, and we sort of thought about how we would continue. And we realized the lesson from this was that if we were to accomplish spoken human-robot face-to-face interaction, we would have to build our own robot. So this is what we did, as you all know by now. Basically, we started with our existing avatar and extracted a physical mask from it using 3D printing, and we basically mounted it on a projector. Mounted it together with a projector, and of course put a hat on it, and that was it. That was the first incarnation of the Furhat robot. So this looks pretty easy, right? Don't say that to our CEO, though. This was his PhD, basically. But a lot has happened since then, of course, but the core ideas are the same. And we know that the face can really make a big difference and have an impact when it comes to interacting with robots. So the fact that the Furhat robot uses a back projection really gives us tremendous amount of freedom, expressiveness, and also the ability to customize characters. So I want to have a little look back and look at some characters we've done, because as soon as we started building the robot, people immediately also asked us, hey, can you make a robot that looks like X? And people had many ideas, and one of the first custom characters we made was actually a Swedish politician. So we basically built a clone of him. This was for some event going on in Sweden at the time, and he was put up in a debate with fellow politicians and business people and so on. And this was a great success. But more importantly, we learned a lot from this exercise. Basically, we learned how to make a custom character that looked interesting and appealing. And of course, we already heard about the uncanny valley. We knew also then, we realized that we shouldn't attempt for full realism, but stop somewhere in a more cartoony, slight caricature. And we think that worked really well. In particular, we're happy about the hair of this one, that we sort of custom 3D printed the hair. We went further a couple of years later in the direction of cartoon characters when we were approached by a big Japanese gaming company, and they asked us to turn one of their characters into a robot. This was an anime Japanese style. And of course, we accepted the challenge, and we worked really hard to make this a likable and expressive robot. And I think we were really happy with the results. Right, so the learnings from that was that we could also go beyond realism and use techniques from animation and manga and anime and so on to take the expressibility even further than you would with sort of realistic expressions. And then, of course, why stop at human-like characters? We already heard earlier from Roger about mammals of different kinds. There are so many interesting life forms. So we built the pug to explore this further. Also, so these experiments really highlight something fundamental. It shows really what sets Furhat apart from many other robots, which is the customization and the ability to turn the robot into anything really, which is quite unique. Not many robots out there can change their face like this. So we can change not only what is projected, but also the surface that we project on, the mask, which is just detachable using magnets. But there's also the expression, the expressibility that comes with an animated projected face is really hard to match with any mechanical device because there are physical limitations to how fast the servo can move, and very few of the existing mechanical robot faces can really match the speed at which the human lips, for example, can move. So these are two aspects that makes the face of the Furhat so unique. And we thought long and hard about this. How can we build on these values? How can we take them further and open this up to users of the Furhat platform even more? So we're pleased today to give a first glimpse of a complete update of the Furhat face engine. It is essentially a new face engine both for the robot and for the virtual Furhat simulator. And it's built from scratch using state-of-the-art game engine technology. We worked some time on this. We call it Face Core, and it's going to be part of a major update of the entire Furhat product in this fall. And it has many interesting features that I will go through some of them today, particularly those focusing on these two aspects, the customization and the expression. So let's have a look at what Face Core has to offer. The first thing, if you worked with a robot before and tried to make your own faces, it has been possible to do this. You can sort of download the texture files, which are essentially the skin of the character, and take them into Photoshop. You can mess around with them and load them back to the robot. And you're often in for a surprise if you do that, because it's quite hard, it's tricky. So what comes now with this update is that you can have texture overlays. You can basically in real time compose textures based on different elements. So you can mix and match and adjust the colors of each element. So if you start with the base face, you can add different styles of facial hair, eyebrows, also makeup, and different features as you wish. So this really gives a lot of flexibility. Of course, speaking of color, actually, I realize now that a lot of the examples here are very pale looking faces. There will be ethnical diversity and gender diversity when this is released, I promise you that. But right now, not so much. Okay, so that's one part. You can change the texture and the colors of the face very easily and flexibly. The second part of the character parameters is that you can also change the shape. So basically you can move around facial features, and this can be very useful, for example, to create cartoon characters, but also to just slightly tweak an existing character to make it just the way you want. And you can also use it to fit another mask. So before there was a one-to-one relationship between the model and the mask. Now you can actually put on a different mask on the robot and then tweak around so that the eyes get in the right place. And you can really explore a lot of things here, which I think is something that researchers will enjoy. And you can preview the changes in real time, both on the robot and the virtual Furhat. So this really gives a lot of flexibility. So the next feature that I want to talk about, I think, is the real game changer here, because it's about expression. And we thought about how can we make the face more expressive, but not only that, how can we make it more intuitive to control it? How can we let people author high quality expression without the need to manually animate? Hand animation is really tedious and expensive or difficult so we thought basically what can be easier than to actually record your own face motion. So this is what's possible now with the use of facial motion capture technology. So you can basically use an ordinary iPhone and record your own movements. And I'm going to let Charlie, that you already met in the opening act, show you how this works in practice. You film your face using the app here. You hear it recording. And you export it. Computer. And once you have it there, you go into the SDK. This is where you build Furhat applications, for those of you who haven't seen it. And then you use a little tool. This will probably look different when the thing is released in September, but the essence is that you generate a gesture file that is in the form of JSON that you can drag into your skill. And all of a sudden, it is there, and you can let the robot perform the gesture. Well, there are a few more steps. You have to, you have to make the skill, obviously. And you run it. So we really think that this is the technology that really changes how you can work with gestures in building interactions. And it's not only that you can record gestures, but you can record speech and fully animated prompts, or even entire performances. So if you stay around until the closing ceremony today, you will even see some singing going on. So you don't want to miss that. A little bit under the hood, what's happening here. So we're using a technology called ARKit. This is something that Apple developed, and it basically describes the face motion using 52 low-level animation parameters. If you're familiar with FACS, the facial action coding system, these are very similar. There's often one-to-one mapping between these, but the important part is that they can be accurately tracked using a regular iPhone. And then they can be played back with a robot or with any other ARKit compatible face model. So this is a very cost-effective and accurate way of doing motion capture. It's really changed the industry, how people do facial animation these days. A lot of game companies use this. But not only does it capture these parameters, the blend shapes, but it also captures gaze, head rotation, and the audio. So you can record speech and entire interactions. You also get the video, so you can compare the results later. Okay. So I want to say a few things about the implications for research. So we're really committed to putting great technologies in the hands of smart and creative people, and to enable people to build great systems and do groundbreaking research. And we really believe that what we presented here, giving a sneak peek of, are research enabling tools that will open up a lot of interesting possibilities. So the possibility to capture expression and bring it into a low dimensional space that is interpretable, which these are, these parameters, and then play it back again. That's a really useful paradigm, because what you can do then is to manipulate the different channels. Suppose that you want to magnify the eyebrow movements, or you want to insert double amount of blinks or something. You can easily do that just in Excel, for example. Or you can do data collection. You can easily record large amounts of speech and movements, and then use machine learning to build a system that can generate motion. So there are lots of opportunities here for researchers and for technical innovation. And by saying that, I want to end by showing you a glimpse of some of the things that we're doing in my group at KTH in Stockholm at the university. So we've been looking at mimicry. So mimicry is fundamental to human face-to-face interaction. So when people interact, they constantly copy gestures and postures and tone of voice, really anything. And this is often a sign of liking and trust between people. And we're interested in how we can model this in a machine. And in a study last year, my PhD student, Patrick, he built a machine learning model based on deep learning that could predict the facial expressions of one person based on the facial expression of another person and the speech. And this worked quite well. It wasn't in real time, but it generates or outputted animation clips of these two characters. And then we thought that with the research tools that we have announced here today, it is actually now possible to turn this into a real-time, real-world interaction with the Furhat robot. So this is what we're currently looking at. I just want to give you some quick preview of this. So at the top here, you see a direct copying. This is not the natural thing, but the robot is essentially following exactly his movements. But below, you see the robot following his movements, but with a 4-second delay. And this is interesting because this has been shown in previous studies to actually be a good proxy or a reasonable proxy of mimicry, that a 4-second delay is long enough so that you don't notice immediately that you're being copied, but you still perceive this character as more friendly and trustworthy. Okay, so the goal now is to conduct a user study with this together with the machine learning model that I talked about earlier, and see how people relate and people perceive this in a real task. So that's it, folks. These features, as I said, will be available in September. If you can't wait for that, you can also ask for a beta access. So thank you very much for your attention, and I hope we have time for a few questions.